I'd like to welcome everybody to the American Cannabis. I'm your host, Ellis Smith. I'd like to thank Cannabis Tech for hosting our show today. Today's topic is a topic that gets overlooked quite a bit, and I think we can raise some very interesting points and topics today to really hit home on how you can improve your businesses. And so today's topic is around process engineering, and we're going to be speaking with Dr. Alexander Makowski. He's the Chief Scientist at Sage Analytics, and is a specialist in process engineering in cannabis. And so thank you so much for getting on today, Alex. It's great to have you.
Well, Ellis, I appreciate the invite, and I'm happy to be here today with Cannabis Tech talking about this because I think it's such an important issue, and especially early on in the industry, there's a lot that we can do with very small changes to help people be safe and profitable.
Great. Now, Alex, if you would give us a little bit of your background and kind of where your career brought you to cannabis and how you got into working in the cannabis sector.
Sure. I did my doctorate in biomedical engineering at Vanderbilt University, and I was creating non-invasive medical diagnostics using lasers and spectroscopy. And shortly after graduating, I got picked up by a company named Process Technology, who was very interested in and already had been applying spectroscopy techniques to process engineering for quite some time, since about 1999. And Process counts among their customers big top 20 pharma names and household brands in food and beverage, for the kind of things that you can just recognize in a store and on your shelf. And the biggest key in why they wanted instrumentation was to be able to regulate their process in real time, effectively catching a bad batch before it ever made it into a package. And it was the idea of our company owner that it would be huge if we could bring that same kind of tech and experience to the cannabis industry, because there was little recourse for these startups and business owners to achieve data in-house without all the burden of having to send things to a laboratory and wait.
I guess at a high level, then, what is process engineering? Help our audience understand, kind of from a high level, what is process engineering, and then we'll dive into some of the first questions I have here for us.
So if you were to take process engineering and try to distill it down into one sentence, it would be the whole concept that Benjamin Franklin made famous, that an ounce of prevention is better than a pound of cure. And the general idea is that it's one thing to observe and make changes, but it's another thing to actually apply the tenets of scientific observation or discovery and modulation to optimize something, particularly in this case, a manufacturing process. So what you're doing is you're engineering the process in the sense that you're creating control points, you're creating redundancies, you're making sure that everything is safe and it's going exactly the way that you want it to go during production, instead of waiting till the end and figuring out if you got there. The effective equivalent is the difference between driving somewhere with an old school, with a paper map or an atlas, and then only realizing that you've gotten lost when you're no longer seeing signs that match what's on the map, as opposed to a GPS, which will tell you immediately if you've strayed off course, and then it'll correct and give you a new course that fixes the path that you're taking. And ideally, any fully developed process engineering scenario will have that kind of observation and control and feedback that allows for corrections to make sure of proper manufacturing, or in many cases even agricultural cultivation.
think that's a great analogy. I think everyone can really understand, how that can now be relevant in their world as far as using a traditional map and a GPS. I love that. All right, let's dive in here. How does process engineering serve as the first line of defense in making sure that everything you obtain is as safe and reliable as possible?
Sure. So the idea is not that process engineering, well, let's just talk about what it's not, right? So this is not going to replace certificates of authenticity or any instances of compliance measurement, because those are designed, and if you look at the regulations for food and bev and pharma and oil and gas, those are designed to be the last line of defense. So then by default, your in-house measurement and your process engineering techniques and systems become the first line of defense so that you never have a bad test at your third-party verification and validation bodies, which in this case are the registered, state certified and accredited and ISO certified laboratories throughout our different states. So in that case, process engineering becomes your ability to have some knowledge and eventually data volume and optimization so you get things right before you send them out. And what ultimately happens is that keeps everything in its lane. And what you will do is you will learn that the certificates of authenticity then remain a source of validation, which is what they're written up to be, not a source of exploratory data finding or, a scientific mission to say, oh, well, what went wrong with this? I don't know. Let's send it to the lab.
So what are the repercussions of having a failed test? Can you lose a license? Like, what can happen? What are the worst case scenario?
Well, I would start with my standard disclaimer here. And if you'll allow me to be so bold, that's the fact that as a young industry, things are changing so fast that by the time someone looks up to read this webinar or to listen to it, I'll probably be wrong if I quote something specific from some state. But if you look at where things have been tracking over the past couple years, and then you also look at where things are in more established industries that provide medicines, pharmaceuticals, nutraceuticals, food and beverage products with vitamins, you can look at it and see that a lot of what happens goes in two different directions. So there are two kinds of repercussions that you would have from any sort of failure. And one would be the actual legal repercussions with a government body, and it could put either your batch at risk. I know that in some states now there are regulations where if you have failed a particular series of testing due to inhomogeneity or things not matching up with labels, after a certain number of failures, you may be forced to destroy material. And admittedly, cannabis is, at the time, right now, it's quite expensive. And then I also know that if we look at the other level of repercussions, it's about protecting the company brand image, not having to issue recalls, because those can be disastrous even if they are due to something that may not be as risky as we picture things. Like something could be less potent than it needs to be. But if you're forced to do some sort of recall because it doesn't match the label, well, then that really hurts your brand. So there's spirit of the law, there's letter of the law, and then there's protecting yourself as a business person, a company, and a brand image.
And losing your brand image, as we all know, it is hard to recover from that. There's quite a few companies out there in the world everyone can, I'm sure, think of that have had their brands tainted in some way or another, from bad food product going out CEOs doing bad things, and so it's really important to really understand that. So, okay, knowing these things, what kind of in-house measurements can be implemented, to really prevent problems before we ever create them, let alone have to fix them?
So a lot of times what you're going to want to do, usually in a factory, there's several different levels of in-house measurements that are done. You would always want to, before or at the time of purchase or acceptance of material, you would want to screen it for contents and screen it for adulterants. And you want to make sure it is what it says it is on the label at the level that it should be. And then you're going to want to make sure it doesn't have anything else that could be deleterious to your product process, or also something that could possibly classify the product as tainted. For cannabis, that would be molds and pesticides or fungicides as adulterants or heavy metals particularly. And on the content side, you would obviously want to be testing for potency, and if it's particular to your product, for a terpene chemical composition that goes on. Now, clearly, as we've mentioned, I work for Sage, and Sage makes potency analyzers. So full disclaimer there, I'm biased. I think we make a good product, or else I'd be changing it. Now, what I would say, though, is that is not just simply measuring potency is by no means the end or the only aspect of in-house measurement that can be done to prevent problems or initiate a concept that is often called quality by design. When you're designing a process, you kind of implement a bunch of fail-safes. There are a lot of in-house measurements that can be done in cultivation that come to mind. You can check the outputs of your lamps with a spectrum analyzer if you think one's going bad. You can check the pH of the soil. I guess the first thing that you would really want to do is you would want to run a series of analyses, just with a bit of a thought experiment on what are the things that could make this go really wrong. With growing plants, it's not easy, but there are some things that are easy to conceptualize that could go very wrong. For example, plants need the right amount of water. Too much water, and then you become prone to mold and mildew, and not enough water, and the plants either won't grow, or worst case scenario, they'll die. So you could have something as simple as a basic flow meter to regulate the amount of water that's going through to make sure the right amount of water is delivered at the appropriate schedule. And that would be an example of process engineering for something as simple as watering plants.
I just took over a grow facility literally over the last month, and ironically, I had to assist over the weekend, and I got to understand the whole flow of the facility and quickly realized how important this process engineering is there, and literally just that flow meter you're talking about on how much water needs to go to each plant for consistency is so important. As you see, a room got watered and some are super saturated as far as the plants go, and then some looked like they were watered, but they're super light and didn't have the same amount of water going into it. And it's that consistency. Those variables are what hurt you, and not being able to measure those is what really makes a business struggle. And so I can relate to that as I'm literally implementing processes this week to correct that.
Wow, well, and I guess that brings up another good ancillary point here, which is process engineering can buy you back your weekends. So,
here's what happened. I can tell you, this is a great kind of place to interject it. This facility at one point ran on 4 people. They brought in a new grower. The new grower didn't understand how to run the automated drip system that the facility had and ripped it all out and preferred to hand water it. And I was ready to, poke my eyeballs out. And so we're back in there getting the pumps turned back on and the drip system turned back on because Now, instead of 4 people to run it, it's taking 6.5 because all of our time is spent watering plants. In commercial cannabis, this is a joke. You should not be hand watering plants. You got to understand your variables and where you can be consistent and where your time management can either make or break your bank every month. And so you've got to understand these things. It's very important. I'm seeing it day to day. This is what we do. We go in and correct a lot of facilities on the cultivation side, and a lot of it comes down to this, this process engineering.
Well, I'm glad to hear you say that, and at the risk of waxing a little bit economic or, God forbid, even political after what's been going on for the past couple of days, but if we value, as the title of this particular cast, if we value this being American cannabis and we want it to remain American, we need to understand that both of our biggest asset and our greatest liability is our highly educated human capital, because Americans work hard and we invent, and we also expect to get paid. So if we don't want everything to be outsourced after we get it all humming nicely, then we need to make sure that, like you said, we're not sending people who have, masters or doctorates in agronomy and plant science and plant genetics out watering just because we had some failure, especially with a crop that can be worth thousands of dollars per pound yield. It's important to get this right, and it certainly should be worth the automated systems or controls that are found in making potato chips.
Literally. I mean, not everybody looks at cannabis growing as manufacturing, and I try to use that term quite a bit with everybody to really help them understand that that's what this is. We're adopting manufacturing processes, procedures, looking at the lean processes that have been implemented from other industries, trying to apply it to this. You may have never known the term process engineering, but people have been doing it and trying to, create structure and systems that, I like to use the term, that are McDonaldized, meaning that it's very replicatable, it's repeatable, it's the same process time and time again. And you have to look at your business in this perspective, else you're going to go down. And automation is the key, and it's going to allow your employees who are highly educated to really put their focus back into what they know and can benefit the company a lot more than watering a plant. And this is what I had to do over a weekend, and I'm overpaid to do something like that, but as my role and responsibility, I have to step in and help out as a team member in these businesses that we come in and assist. And that's why I think I get some respect from the growers that I work with, because I'm not just the guy in the fancy shoes and the fancy shirt. I'm willing to get dirty and get my hands dirty and work side by side with them and show them that you have to sometimes bear down and help. At the end of the day, we got to look at this process engineering component, because you're going to eliminate me having to get dirty all the damn time.
Sure, yeah, and I like how you threw in there that you're not just the guy in the fancy shirt and fancy shoes. So you're also implying that you're still happy to wear a fancy shirt and fancy shoes.
Sure. I prefer to get dirt under my nails every day. That's my background. That's where I come from. Fortunately enough, I've become a businessman in this industry, but my core and my heart is the plant side, and that's my specialty in this business in my company. And so I miss that side of it. It helped me to understand process engineering for this group I'm working with. I've been there for 4 weeks, and I finally had a chance to get my hands on it and on every aspect of the business. And in order to really help a company, you've got to do that. You've got to go through every single motion that the business has to truly see where the improvements may need to come, if any. And that's what it takes, and that's what I really love about my job, going in and doing these things. I'm a process nerd. I need structure. I like things to be repeatable, and you can do it over and over the same. So, yeah.
Yes. Boring is the best.
I hate to say that. Well, I'm sorry. Go ahead.
But that's what I'm saying. I guess, and before we move on to the next topic, I would just want to interject to put a little bit more meat on the bone here. I would say that a lot of what you want to look for moving forward, if you're looking to implement this in your system, is you're going to want to look for ground level systems or sensors that can measure what you consider an issue to your process. But you're always also going to want to look for closed loop systems or things that have a certain ability to connect to larger manufacturing scale systems. Process engineering is a whole industry. And even though we haven't fully adopted it in cannabis, it doesn't mean that if you're out there and you're listening that you can't choose to do so. You can look up companies, they call them systems integrators, and they're the guys that make sure that if you get a flow meter, it can tie into a computer so that you're not walking out there anyway to stand in front of the flow meter to read the values. And what you really want to do is make sure all the data comes back in a way that it can be aggregated.
And that's where I see a lot of times people go and collect great information. They've got these log books. So they're kind of old school with collecting temperature and humidity and pHs and parts per million and all this great information. And they'll get a harvest and they'll see their yields. And they don't go and compare and really look and see, okay, why did this room grow, 10 grams more per square foot than the last room? They don't go and understand how they can use this data that was collected to improve all the way through. Ideally, they should know why they either failed or they didn't fail by having these checks and balances along the way to say, man, I had high temperatures for the first 2 weeks. I know our yield's going to be impacted. Putting these checks and balances in place are what's really going to allow you to be more successful, to really be on top of issues and problems, and really just try to mitigate risk in those variables.
I couldn't agree more.
Okay, let's kind of walk our audience through, what it looks like about the manufacturing process from purchase trim to manufacture branded products, and how to eliminate variance and output from the beginning by measuring. And so you've got a bunch of different things we can look at measuring, from the raw ingredients that you're buying, the raw ingredients from degradation. If you could walk us through kind of that step-by-step here of this manufacturing process and really show our audience what this looks like.
Sure, and I think raw ingredients is an important point to touch upon, because regardless of how much we chip away at the black box of our particular manufacturing process, the old adage of engineering modeling remains true, garbage in, garbage out. So the first, and arguably if you're only going to take one point home from everything that I say today, it's that any manufacturing process depends upon regularity of the input to the process. You really can't take any of the further steps at tuning things up if your input is all over the map. And in that case, this would be the raw ingredients, or, because we're going to talk about simulating making a branded product or some sort of edible or smokable product that is branded and stamped like a vape pen, then you really have to start with quality in the raw ingredients. And quality may not mean the most potent raw ingredients. It may mean that the potency and percentage of the cannabis that is terpenes, lipids, plant, cannabinoids, water is consistent. And in that case, you would want to check the raw ingredients before you're buying them. This is also the place where you can make and save the most money, because if something's not just right and you're going to have to put time and effort into making it right, then it should be worth less to you. So you're going to check, you're going to measure, you're going to have a specification, and then you're going to check each small bit of product that's coming in to make sure it falls within the accepted and agreed upon range. And before we have a bunch of people just fly up and reject this whole concept, because they say, that's crazy, this is a natural plant, how are you going to turn it into something? You're gonna throw all your product out the window if you reject product. Well, a lot of times it's the average value if you're going to extract a product that matters. So if you got something that was a little bit high in potency and something that was a little bit low, and you could bag and tag each element or each bag that you get coming in, You could create a small Excel spreadsheet that would go and you could weight mix the product to make sure that what you put into the extraction was always on average the same potency. And that's the kind of low-level process engineering I'm talking about that is achievable today without a significant investment or without automation or Allen Bradley computer systems, which would be wonderful, but that would be a large investment that would require a large amount of product to make it financially viable. So I guess as we go through these things, you start at raw ingredients, you measure them before you buy them, you measure them after you buy them, you make sure they're within the range, you sort them, and then you can weight mix them into the next step. And that's kind of a general process that we're going to hear repeated over and over again.
Okay.
So the next thing you're going to want to do is now you have the products, they're inbound. Sometimes, despite best efforts in manufacturing, we all like to believe that things are manufactured as soon as the inbound product arrives. But delays are probably the biggest issue in manufacturing. And as an ingredient to any step, right before you use it, you're going to want to remeasure it to make sure that there hasn't been any significant change in it. In the amount of time that it's been sitting, either waiting to be approved from quarantine, or it could possibly have been exposed to something that would allow it to change, degrade, dehydrate, etc.
Okay.
So that gets us to the point where we're actually making something. Yes?
So now, I'm sorry, go ahead.
Oh, no worries. So we've talked about mixing to obtain homogeneity of potency for process input. And then once you've extracted, you're also going to look at mixing chemicals to ensure proper chemical reactions. This is done for solvent saturation. This is done in any sort of baking. It's a process used in making your decaf coffee or for any sort of dosing. So you know, any time where you're intentionally causing some sort of chemical reaction or a chemical separation, you're going to want to make sure that you, for example, would check your solvents. Let's say people often do either ethanol extraction or ethanol cleanup. Well, I can guess that, you know, there's a lot of different cases where obviously people are having the cannabis tested because it's required, but I would be interested to know how many people out there are regularly having their ethanol tested to make sure it is at the appropriate potency percent ethanol, make sure it's well mixed, and that all the, you know, if there's water in it, it hasn't settled out, and that there aren't other chemicals mixed in there that could create off products that mess with your particular desired reaction.
Okay.
So then once we have an extracted product, we go into checking and weight mixing the intermediary products, the extracts you already have, because batches and sub-batches may be different as things happen. You may have to have algorithms that can adjust things in these closed-loop systems you're gunning for, like temperature, pressure, time, quantity and flow of solvent. And then when you get things out that do differ, it's important to measure those intermediary products. And in order to stabilize a process, you know, in any case where it's allowed, you would want to weight mix those intermediary products to make sure that everything moving on to the next step is as close as possible to optimal. You're also going to always keep data on those processes and then tweak them for an optimization of yield for whatever it is exactly that you want. Once you've done this, then you've allowed yourself to understand the potency at every step. In this particular case, we're discussing potency, and you've optimized every step coming up to it. So now you would take more regularly available devices and sensors that allow you to quantitatively add in these excipients or your inactive ingredients, any sort of preservatives or chemicals that are needed to stabilize the medicine. You know, in the case of making something as simple as mustard, it's important to add acid so then the mustard doesn't degrade over time, so that when you open up the bottle of mustard, it's just as spicy as you want it to be. So if that's possible, to take a plant that yields a seed with a particular characteristic we like that's going to be variable and have different strains as well, and turn it into a shelf-regulated product, that even though cannabis is a lot more complicated, we can learn a lot from that. Finally, once we've made the product that we're manufacturing, we want to check it again before shipping. There are important points to go over here, especially as far as testing and keeping track of what you make. It's crucial to start following good manufacturing processes, or CGMP guidelines. And the sooner we do that, and the sooner we start holding ourselves to, you know, United States Pharmacopoeia guidelines, or these sorts of processes that are used even for vitamins and supplements, these people adhere to those, the manufacturers adhere to those oftentimes voluntarily, just to ensure quality, because if it's good enough for making pharmaceutical grade medicines, then it should be good enough for making supplements. One of the things you're going to want to make sure you do is you want to keep retention samples of each batch you made and use those to measure degradation. You want to perform shelf life studies, because that's going to determine how long your product can sit on a shelf in-house, or how long it can sit on shelf at either dispensaries or points of sale, and once it's been given to the customer, before it may degrade in some way. The importance here is to know how your product degrades, but since your product is going to be its own formulation, in essence, no one can tell you that unless you schedule up the experiment and you run through with it. There's not going to be a book or formula that's easy going to be that you can just go look up what the degradation time is for a particular manufactured, or as I like to refer to them, minted products. Once you've taken a pure substance, in this case cannabis, and you've added it to a food product, you've changed everything about the shelf life, storage, degradation mechanics, and you're going to have to figure out what it is that either keeps your product good for longer or puts it at risk of being less than it was the day you manufactured it.
I have a quick question on that. Someone's
sure.
asking, what's the optimal shelf life study time for these points? I think you got to let time kind of tell you that. I think, you know, for most products, they're going to look for a 6-month expiration to a year expiration. Past that, I don't think you want to have something longer than that. So I think you want to ensure that your product can at least sustain 6 months to a year. But I'll let you kind of point it out more.
So what I would say is the funny thing with degradation studies is that they're not over till they're over. It's kind of at the beginning, just like in any good science, it has to be observational and it has to be something that is exploratory. And in that sense, the issue is that if you don't know whether or not, just because it doesn't degrade in 6 months doesn't mean you shouldn't keep testing or retesting bits and pieces of these retention samples from the batches you've made. If you change something about your process, then you might have inadvertently changed your shelf life. So these things should constantly be going, ideally, these things should constantly be going on in the background as you're making tests, you're making batches. you're producing product, you should be able to keep amounts of this in-house and run it through tests a certain number of weeks, months, even a year or two later to find out what is, and in engineering we strictly call this a safety factor. So let's say you don't want for your brand image or for proper dosing your product to remain on the shelf once it has changed more than, I don't know, we'll just throw out a number like 10 or 15% in its potency. So then if that is the end goal, then you would probably want to regularly and repeatedly measure these products until they had at least a 30 to 50% degradation in potency, because then you would have enough data points and enough time to regularly and reliably and repeatably say the product doesn't degrade by the 15% that I'm considering an end point of the usable life of the product. It doesn't degrade that until X number of months. Now, I don't want that to ever happen. And once that product leaves my hands, I'm not in control of how it's stored. In which case, I might want to build in what's called a safety factor and say the shelf life of that product is 2/3 of that time. And this is difficult because there are obvious shelf lives for other basic edible products like bread, right? The bread is bad when it's stale or it starts growing mold. And, it kind of stacks up in what the risks are to you as a company. You don't ever want there to be any sort of safety risk to a client, but usually the motivating factor for things like shelf life is more on consistency of experience and promoting a positive experience with the product, regardless of what product it is. And usually brand image kind of edges in before you'd ever get close to something that would be a safety concern.
Okay.
What do you think about that? Where do you think that stands?
It's hard to answer that, Yeah. I have no opinion, I guess.
Fair enough.
Okay, knowing that you have all of these processes to consider, I mean, this is a lot to put into your day-to-day business to really get through, a regular product cycle. How are companies, managing this and making money on this and still maintaining to put out a regular product? Like, how can people achieve this?
I would say they achieve it gradually. The key is having a couple, because all of us are growing and changing in this growing industry. And we're also responding to, as we mentioned earlier, constant changes and growth in regulation to increase safety as, we as an industry and also we as a nation learn more about this product. To grandstand just a little bit, a lot of what is essential and a lot of what we need to do is unknown, which will probably lead to a lot of wastage as everyone figures out what is important in preserving their product. And if I could throw out just one thing, there's an issue because a lot of the resources that would usually be thrown at this by our great universities and our research institutions, their hands are tied due to the legality of cannabis. And also then any sort of potential negative image that might remain in certain regions of the country. And I would say companies are managing to do this. They don't talk about it. As we said earlier offline, we don't talk about process engineering because it's not sexy. It doesn't get the turnout, but I think what it is good for is it's ultimately a self-fulfilling prophecy, because while it costs money, there's a good return on investment. the return on investment is only higher when you're working with a very expensive product that has expensive raw ingredients and that can sell for a high price when properly manufactured. And cannabis would certainly be considered an expensive product. And in that case, I would say, you're trying to do something where there's precedent that you can draw from other industries, and you're trying to do it primarily for your own good and the viability of your own product, not because someone else is requiring you to do it. And then the only other thing that I would mention is that you really need to look at, as you're going to implement something, what is the business plan? What is the return on investment? How long is it going to be before I'm going to need to actually replace this system, and what does it garner me? And a lot of these companies, especially the system integrators and the industrial measurement companies, they're prepared to do this for their clients. So I would suggest that people go out there. They don't be afraid to communicate with them, and they don't expect to have to do this entirely on their own by hiring a ton of in-house experts. There are lots of consultants out there. There are a lot of system integrators that are happy to pair you up with technology that works. And in that industry, just as in cannabis, word of mouth is certainly the most important thing going. No one wants to work with someone who will sell them a bunch of equipment that's useless to them.
Sure. Kind of build on that, it can be expensive for sure to have to run a business this way. I can tell you the facility we just have taken over, they had some contamination issues with their flour coming back on their high CFU counts and their microbial counts. And it cost them quite a bit of money to constantly be testing such a high number of tests that the state required. After they proved to the state and got process validated, they were able to now reduce how many tests they were taking per batch, and that saved them quite a bit of money. And so you can see how having 4 processes in place can cost you quite a bit of money. And when you do have it in place, your life can be easy. And, that your checks and balances in place will allow you to successfully run your business, because you can see along the way where the issues may arise. You can quickly address them and hopefully overcome them with a corrective action versus waiting to the very, very end and then trying to play forensics on trying to figure out where that problem occurred. And so it just really shows how it can impact your financial being and your bottom line month to month, depending on how well your processes are in place or not.
Yeah, I couldn't agree more. The only thing that I would add is that there's a certain level of human element to it too. And if you're a business owner or a business operator or even a consultant, there is a certain value to being able to achieve stability for your human capital as well. I know one of the cultivators that we worked with very early on, the thing that he's most proud of about measuring his potency is not that his average potency has come up 7 points. What he's most proud of when you go and you talk to him, because he is operating a small business and the individuals and relationships matter to him, is that now that he has a regular known harvesting procedure, he can actually schedule things up so that in his greenhouse operation, they're harvesting every week, which means that all of those part-time people that he had real relationships with that were trimmers are now full-time employees of his business because he has work to give them every day, which he never would have had if he didn't have the opportunity to measure and regulate and then create a structure that allowed him to time out that product so things are coming down regularly.
It's a McDonaldized process in my eye, especially growing the plant specifically. I want to kind of touch on the plant part a little bit, as a lot of our conversation really was around manufacturing and stuff, but we have touched on the growing side of it and how it's just important in that side of the business as well for all these processes in place. And that's kind of what my role is. I said I'm in a business now where I'm bringing in so much structure to a process that I know is the same from the first day I cut a clone until the last day I harvested. Everything is premeditated from how long it's in each stage, what type of food the plant gets, what type of lighting it requires, and just really allowing checks and balances to ensure that the plant is meeting your expectation along the way as far as the canopy height, the canopy shape, the canopy looking as far as the health-wise of the plant. You can manage your pests this way. There's so many things you can put in check to really make sure you're successful. And I think on the growing side, most folks may overlook this component, and it's super important as this is a manufacturing process.
Absolutely, I couldn't agree more. And if I were to go back through the analogs of what would happen, you could take each one of those things we talked about, the raw ingredients and measuring them before buying, and you can consider soil and fertilizer a raw ingredient. If you have to spray the plants with something, you're going to want to mix that up to its appropriate dilution, because usually it's sold concentrated. But ideally, if there were some way for you to measure the level of concentration of that, then you would want to do that. Maybe if you communicate with the people who are selling it to you, maybe that results in a change in pH, and you could use something as basic as a pH strip just to double check something before you spray it on the plants. Because again, the whole concept is measure before and don't pay the price afterwards.
100%. That simple analogy there with the pesticide specifically, you'd use the wrong milliliters or percentage per gallon of water, you will burn and ruin a crop. I see it happen time and time again, and we like to have logbooks in place that once you do mix that, you put the rate of mixture that you did. There is a pH section for you to fill in that number, and a part per million if I'm looking for that as well. And so there is the ability to track that information, create those checks and balances to ensure those variables are being managed properly. And I think a lot of people just overlook a lot of these details. As we know, these businesses the devils are in the details. This is what really makes these things tick.
Well, we see this time and time again. I'll often quote that it used to even be, especially here in America, it used to be something where being regular and normal and in a sense what we might now consider boring was actually core to a brand image. When you look at Rockefeller and you look back in the day, a famous American business forefather, you can see that there was a brand, Standard Oil. The whole brand was built around the fact that you know what you're getting, it's always the same. It's standard. We have a standard, and we make sure we put something out to that standard. Because if you're going to put oil in your car and then the oil's bad, well then, you've ruined the whole car. Or you have to take it to a mechanic and have everything siphoned out and cleaned out, and if you're lucky. And then there's a huge bill, a huge delay. In that sense, now we've progressed so much to where the fact that in many ways, at the risk of sounding like I'm way older than I am, we're now spoiled because we can pull things off the shelf and count on the fact that they are what they say they are on the label. And that's only true because of process engineering. And the burden of developing those methods and that safety, maybe a burden, maybe also an honor, is on the people who blaze a trail in a new industry. And that's where the cannabis industry is right now.
And to kind of build on that, let's touch on the conversation you and I were having right before this thing started about just the edibles market in general and how it's still somewhat inconsistent with some of the products. Now, some brands have figured it out, but for the most part, for me as a consumer, the edibles have been inconsistent for me to figure out dosing and the overall desired effect I'm looking for. And I've tried so many different products, and it's still hit or miss for me. And I can't figure out what are the ingredients I'm looking for that are giving me the desired effect, and what is that milligram dosage. I see a lot of these folks are, sourcing material from, say, 25 different varieties of cannabis, and they're homogenizing all these down into, one oil. it's a spectrum of experiences kind of put together that is inconsistent for a consumer. And so I look at it from the standpoint of, imagine going and buying a Snickers, and every time you open it up, you're like, well, I got Oreos this time in this wrapper. And the next time you open up that Snickers, you're like, I've got a Kit Kat. And this is the way I view that experience from an edible standpoint. I think it goes down to this process engineering.
Well, absolutely. And, over here, whether I'll just throw out there, in 2016, Joe Rogan did a comedy stand-up night. It's titled Triggered. It's recorded. You can go look this up. He has a particular skit that I find is close to home for what we're trying to prevent here at Sage, and the mission of getting people the ability to measure. And it's basically summed up as gummy bears and talking to dolphins. And while I have none of his level of humor, he was basically saying that the edibles he was getting were so strong when he came to San Francisco that when he would go in and ask someone what's up with these gummy bears, how strong are they, the response was a cringe. And he said cringe is not a viable or quantifiable unit of measure. And I'm paraphrasing lightly here. And he said, well, how much should I take? And they said, well, cut off just the leg of the gummy bear. And he's like, well, then why are you selling whole bears? And the idea is that sometimes, process engineering and quality by design has to have two different elements. And I'm not saying that with a level of automation or machinery that you're going to ever replace humans, because that's not the goal. The human component always comes in when you say, well, how do people eat gummy bears? Well, you don't eat one. You certainly don't go into the kitchen and grab a knife and carve the leg off of a gummy bear. You throw a handful in your mouth, right? So then, is it a good idea to make a gummy bear where for most of the human populace, half a gummy bear is a medical dosage? It boggles the mind. We've worked with so many people where what they've really done after they get the potency equipment we sell is they've achieved a level of precision that instead of making a dinner plate sized cookie that has to be carved up into dosages for people who are using this recreationally or, God forbid, medicinally, and they're attempting to relieve pain and they have to wait several hours to begin with, then they're now able, with this increased precision at implementing process engineering, to make regular, reliable, and repeatable single-dose, single-package edibles where if you rip open the package and you eat the edible, you've taken what they want you to have as one dose. And not only is it reliable and repeatable, but they don't have to worry about things. They don't have to say, well, on average, we can make something that on average will pass a test because if they grind up the whole cookie, it'll have about 200 milligrams in it. But then we're not really sure if this corner of the cookie has the same number of milligrams as the other. One of the funniest issues that I've encountered is a lot of people are in warehouses or old factories, and then we have to discuss with them, well, you got to make sure you level out everything. Your facility needs to pass the roll of marble test, just like if you're looking to invest in an old house and you want to see if the floors are level. Well, if you're pouring something out as a liquid and it's settling up as a solid, like a lozenge or a candy or a chocolate bar, then you don't want everything to be off the level, or all the medicine might settle into only one side or one part. And this inherently generates an issue where you get to a point where part of the candy bar might have less medicine in it and the other part might have much more. Well, if people take the part that has less and it has no effect, then they say, oh, well, this edible is a dud, so I'm just going to eat the rest of it. And now they've taken 10 or 20 doses. And that's what generates the negative experience that will have a strong negative impact on the industry, and producers will be held accountable unfortunately, for the possibly uneducated and definitively negative decisions that are made by end consumers that can't be expected to sit down and think about the manufacturing conundrums of how chocolate bars are made. They just want to eat a chocolate bar.
That's it. And I think that's where, over time, we need to get better regulatory bodies to step in and really treat this like any other food product being put on a shelf. And that's what I think is a limiting factor as well from these inconsistencies. We just don't have those governing bodies to really enforce like we do with all these other products.
Well, we are in a stage of transition and growth, and I think the idea of a lot of the regulations, especially out in California, is that our regulatory bodies want to work with, and they have in their mission statement that they want to support local and small businesses to keep the existing industry alive. And in that sense, they don't just want to slam people with federal regulations that might not be an appropriate scale match for their business. So it creates a bit of a conundrum on both sides, because while we all want everything to be safe and reliable, some processes could be developed differently than others, so there is no one-size-fits-all formula, and the level of time and effort you need to implement this is significant. So I guess the only thing that I would say, while I agree with you entirely, that we're going to have to, as an industry, tighten up our game a lot over the coming years, it's that the onus and the burden will always be on the producer and the manufacturer, and he who waits until the government comes out with a regulation in order to comply with it will always be behind the curve and suffering under the financial burden of having to buy something and implement something that could take months and do it in a couple weeks.
So true, so true. You might as well start those good habits now, be in position and lead by example, so that when the time comes, you don't have to make any adjustments. And this is the way we really try to guide a lot of our customers and clients as a whole. So I agree with you there. Well, Alex, here as we're kind of wrapping this up here, I've got one question here I want to answer as it came in. It's sort of related to process engineering. And it's kind of an opinion-asked question, so I'll read this out loud and see if you have any input, and I'll give some input on this as well. So, in your opinion, what's the best container to preserve the shelf life in various conditions or consistent ones? Air-sealed cans. And this may not be something you are familiar with, and I'd be glad to answer that if not.
So for raw material, I'm not too familiar with storage, but I guess from a scientific standpoint, I will say that a lot of people are surprised in hearing that one of the strongest degradation mechanisms of activated cannabinoids is actually oxidation. So I always recommend that all of my clients, once they hit the point where they've extracted or activated the cannabis, that they try to either evacuate, vacuum off, or nitrogen purge containers. I also recommend that things be stored in the cold. The colder you can get it, the better. Freeze-thaw cycles are never good for any material, so they should be minimized. But if you can freeze stuff down, that's only going to help. And then the third thing that we have shown and have seen is important for many products in this industry is UV-based degradation. So keep stuff out of light, keep stuff dry and cold, if not frozen, and package it in a way that prevents any sort of exposure to oxygen, if at all possible. And depending upon the product, if you can kind of meet those particular requirements, then there are a large number of storage containers that could be excellent for this purpose.
I agree 100%, and I'll give just my 2 cents on what we've seen in the marketplace as a whole. From a consumer standpoint, I'll tell you, we did some internal trials where we were purchasing the cans when they first came out that were nitrogen packed. They were like skull cans, and we kept a series of them and opened them every 3 months, and we kept one up to a year and a half. And I tell you, the terpene profile was still there. It had the same squeeze I was looking for as far as it didn't degrade as far as drying out because it wasn't exposed to UV. There was no degradation in that aspect of it. And we were really impressed by the overall product. Now, on the flip side, I will say if you put a product that's not properly dried and cured into that can, we have seen other brands use this technology and have mold and mildew grow inside that can because they didn't properly have the material moisture removed. And so, yes, these things I feel are going to be some of your best options. Just ensure that you know what that water content is of that product going into that can to prevent that from happening.
Absolutely. That was the other thing I was going to throw out there. Any sort of moisture containment, either in process or quality by design, or using some addition that is controlling that, will help you in the long run.
Well, Alex, let's wrap this up. Do you have any kind of last words for our audience here, words of wisdom? I'd love to kind of hear your take on this and give your kind of 2 cents on, just this conversation today, the recap.
Well, I really appreciate the opportunity, Ellis. If I was going to leave the listeners with one more thing, it would be that I think process engineering and operations should be run the same way that voting is done in Chicago. Vote early and vote often. So measure early and measure often, and you'll be amazed at what you can discover and what you can easily change and control. And that's all I have.
Well, I appreciate you getting on today. This is what topic today was importance of process engineering with Dr. Alexander Mikowski. He's the chief scientist at Sage Analytics. I'd like to thank Cannabis Tech for being our host and working with us to produce this show. Thanks to our audience for tuning in today, and we will see you next time. Thank you, everyone.